Good morning, children. Today, in Introduction to Trigonometry Part 3, we are going to study about trigonometric ratios of some specific angles. We have already learned the trigonometric ratios of sine, cos, tan, cosec, sec, and cot. Let us learn about trigonometric ratios of some specific angles like 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Let us start. Trigonometric ratios of 30 degree and 60 degree. For this, consider an equilateral triangle ABC. Since it is an equilateral triangle, we can say all the three sides are equal and all the three angles are equal. Therefore, angle A is equal to angle B equal to angle C equal to 60 degree. When we draw a perpendicular AD from A to the side BC, we can say ABD will be congruent to ACD. From this we can say BD equal to DC and angle BAD is equal to angle CAD using the condition CPCT. Let us take the length of the sides of the triangle as 2A. Therefore, we can say AB equal to 2A, AC is equal to 2A, BC is equal to 2A. From this, we can say BD is equal to A. Let us take the right triangle ABD. Angle D, since we have drawn the perpendicular, angle D will be 90 degree. In the right triangle ABD, let us find the missing side AD. With the help of Pythagoras property, we can say AB square is equal to AD square plus BD square. Or from this AD square means AB square minus BD square, which is 2A whole square minus A square, which is equal to 4A square minus A square, which is 3A square, and therefore side AD is equal to A root 3. By drawing a perpendicular AD in an equilateral triangle ABC, we got a right triangle ABD where the measure AB is equal to 2A, BD is equal to A and AD is equal to A root 3. Let us find the ratio sine 30. That means here we can see in triangle BAD, angle A is 30 degree, opposite side by hypotenuse BD by AB equal to A by 2A equal to 1 by 2. Cos 30 is adjacent side AD by hypotenuse AB, which is equal to A root 3 by 2A, cancelling A. The ratio cos 30 is equal to root 3 by 2. Now tan 30, that is opposite by adjacent, BD by AD equal to A by A root 3 equal to 1 by root 3. Therefore, the value for tan 30 is 1 by root 3. We have seen cosec 30 is equal to reciprocal of sine 30. Therefore, we can say it will be 2 by 1, which is equal to 2. Sec 30 is the reciprocal of cos 30 equal to 2 by root 3. And cot 30 will be the reciprocal of tan 30, which is root 3 by 1 equal to root 3. Since we got all the ratios with respect to the angle 30, let us find with respect to 60 degree. For this, angle B is 60 degree in the right triangle ABD. Sine 60 is opposite by hypotenuse, which is AD by AB equal to A root 3 by 2A, which is root 3 by 2. And cos 60 will be adjacent side by hypotenuse, which is BD by AB, A by 2A equal to 1 by 2, and tan 60 equal to opposite by adjacent AD by BD equal to A root 3 by A equal to root 3. Once we get the value for sine 60, cos 60 and tan 60, we can find cosec 60 will be 2 by root 3, sec 60 will be 2 by 1, which is equal to 2, cot 60 will be 1 by root 3. Trigonometric ratios of 45 degree. Let us take a right triangle ABC, right angled at B, and let one angle be 45 degree. then we can say the other angle also will be 45 degree. If angle B is equal to 90 degree and angle A is equal to 45 degree, automatically angle C will be 45 degree. That means if angle A equal to angle C, which is 45 degree, we can say opposite sides are also equal. Therefore, BC is equal to AB. Let the sides BC and AB be of measure A. To find the side AC, let us apply the Pythagoras property. AC square is equal to AB square plus BC square. That is A square plus A square equal to 2A square, and therefore AC is equal to A root 2. To find the value for sine 45, we know it is opposite side by hypotenuse BC by AC equal to A by A root 2. Cancelling A, the value for sine 45 is 1 by root 2. Now cos 45 is adjacent side by hypotenuse, which is equal to AB by AC, which is A by A root 2. Again, cancelling A from the numerator and denominator, the value of cos 45 is 1 by root 2. Tan 45 is opposite side by adjacent side, which is BC by AB equal to A by A equal to 1. Therefore, cosec 45, which is the reciprocal of sine 45, will be root 2. Sec 45 will be the reciprocal of cos 45, which is also root 2, and cot 45 will be equal to 1. Trigonometric ratios of 0 degree and 90 degree. Let us see what happens to the trigonometric ratios of angle A if it is made smaller and smaller in the right triangle ABC till it becomes 0. From the figure we can see in the right triangle ABC, if angle A is made smaller, the length of the side BC goes on decreasing, and we can see the point C gets closer to the point B. When angle A becomes very close to 0, AC is almost same as AB. Therefore, we can say sine A is equal to opposite side by hypotenuse, which is BC by AC. Where BC is 0, we can say it will be very close to 0, and cos A, which is equal to adjacent side by hypotenuse, where AC is almost same as AB, we can say it is very close to 1. So we can say sine 0 degree equal to 0, and the value of cos 0 degree is equal to 1. Similarly, if angle A is made larger and larger till it becomes 90 degree, we can see from the figure angle A becomes larger, the length of the side AB goes on decreasing. The length of the side AB is going on decreasing. The point A gets closer to the point B. Finally, when angle A is equal to very close to 90 degree, we can say angle C becomes very close to 0 degree, and the side AC almost coincide with the side BC. Now the value sine A is equal to opposite side BC by hypotenuse AC is very close to 1, and cos A, which is adjacent side AB by AC, is very close to 0. Therefore, we can say sine 90 degree is equal to 1 and cos 90 degree is equal to 0. Let us see a table for the trigonometric ratios of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. We can see sine 0 is equal to 0, sine 30 is equal to 1 by 2, sine 45 is 1 by root 2, sine 60 root 3 by 2, and sine 90 is equal to 1. We can see that the value of sine ranges from 0 to 1. To recollect easily, we can see the next ratios cos, the values will range from 1 to 0, and it will go in the reverse order of sine. That is, cos 0 is equal to 1, cos 30 is equal to root 3 by 2, cos 45 is equal to 1 by root 2, cos 60 is 1 by 2, and cos 90 is 0. For the value of tan, we can say it is sine divided by cos theta, 0 by 1, which is equal to 0. Therefore, tan 0 equal to 0. Tan 30 is 1 by 2 divided by root 3 by 2, which is 1 by root 3. tan 45 is 1 by root 2 by 1 by root 2, which is equal to 1. Tan 60 is equal to root 3 by 2 divided by 1 by 2, which is root 3. And we can say tan 90 is 1 by 0, which is not defined. To find the cosec, sec and cot, we can just take the reciprocals of sine, cos and tan. That is, cosec 0 is equal to 1 by 0, which is not defined. Cosec 30 is equal to reciprocal of 1 by 2, which is 2. Cosec 45 is the reciprocal of 1 by root 2, which is root 2. Cosec 60 is the reciprocal of root 3 by 2, which will be 2 by root 3. And cosec 90 is 1 by 1 equal to 1. Similarly, we can find all the values of sec as well as for cot. Exercise 8.2, page number 187. Evaluate the following: sine 60 degree, cos 30 degree plus sine 30 degree, cos 60 degree. For this, you should know the values of sine 60, cos 30, sine 30 and cos 60. We know sine 60 is equal to root 3 by 2, cos 30 is also root 3 by 2, sine 30 is 1 by 2 and cos 60 is also 1 by 2. So root 3 by 2 into root 3 by 2 is 3 by 4, 1 by 2 into 1 by 2 is 1 by 4. Adding them, we can say 3 plus 1 by 4, which is equal to 4 by 4, and the answer is 1. Question number 2. 2 tan square 45 plus cos square 30 minus sine square 60. We know the value of tan 45 is 1. To find the value of tan square 45, we want to square the value of tan 45. That is, 1 should be squared. In the same way, cos 30 is root 3 by 2. Therefore, cos square 30 will be root 3 by 2 whole square. Sine 60 is also root 3 by 2. And sine square 60 is root 3 by 2 whole square. So, substituting these values, we can see our answer as 2 plus 3 by 4 minus 3 by 4. Plus 3 by 4 and minus 3 by 4 get cancelled, and we get the answer as 2. In the next one, cos 45 by sec 30 plus cosec 30. Cos 45 is 1 by root 2, sec 30 is 2 by root 3 and cosec 30 is 2. Seeing two fractions in the denominator, let us find the LCM for the denominator. LCM is root 3 and our denominator will become 2 plus 2 root 3 by root 3. Now our question is of the form 1 by root 2 divided by 2 plus 2 root 3 by root 3. That is, divide a fraction by another fraction. In case of division of a fraction by a fraction, we take the reciprocal of the denominator and multiply. That is 1 by root 2 into root 3 by 2 plus root 3. So our answer will be root 3 by 2 root 2 plus 2 root 6. Seeing irrational number in the denominator, we are going to rationalize it. That is, multiply and divide by 2 root 2 minus 2 root 6. So our numerator will be root 3 into 2 root 2 minus 2 root 6, and the denominator will be always of the form a plus b into a minus b, which is 2 root 2 whole square minus 2 root 6 whole square. So the denominator will be 4 into 2 8 minus 4 into 6 24, which is equal to negative 60, and the numerator will be 2 root 6 minus 2 root 18. Root 18 can be split as root 9 into 3, where root 9 is 3. So the numerator can be rearranged as 2 root 6 minus 2 into 3, that is 6 root 2 divided by negative 60. Taking 2 as a common factor in the numerator, we can write 2 into root 6 minus 3 root 2 divided by negative 16. Cancelling 2 and 16 and changing the negative sign of the denominator, our answer will be 3 root 2 minus root 6 by 8. Question number 4. Sine 30 plus tan 45 minus cosec 60 divided by sec 30 plus cos 60 plus cot 45. First, let us substitute all the values of sine 30, tan 45, cosec 60 and so on. Sine 30 is 1 by 2 plus tan 45 is 1, cosec 60 is 2 by root 3, sec 30 is 2 by root 3, cos 60 is 1 by 2 and cot 45 is 1. Seeing so many fractions, we can take the numerator. Numerator is 1 by 2 plus 1 minus 2 by root 3. Finding the LCM, it is 2 root 3. Our fraction will be root 3 plus 2 root 3 minus 4 by 2 root 3. Now take the denominator, which is 2 by root 3 plus 1 by 2 plus 1. Again, finding the LCM, we can write it as 4 plus root 3 plus 2 root 3 by 2 root 3. We can see a fraction divided by another fraction. That means numerator is multiplied with the reciprocal of the denominator, which can be written as root 3 plus 2 root 3 minus 4 by 2 root 3 multiplied with 2 root 3 by 4 plus root 3 plus 2 root 3. 2 root 3 from the numerator and denominator gets cancelled. So our fraction will be root 3 plus 2 root 3 minus 4 by 4 plus root 3 plus 2 root 3. Here we can see root 3 plus 2 root 3 can be added and can be written as 3 root 3 minus 4. The same way, denominator also can be written as 4 plus 3 root 3. Seeing an irrational number in the denominator, we are rationalizing it. That means multiply and divide by 4 minus 3 root 3. Our numerator will be 3 root 3 minus 4 into 4 minus 3 root 3. Denominator will always be of the form a plus b into a minus b, which is equal to a square minus b square, which is 16 minus 9 into 3, 27, and the denominator will be negative 11. Opening the bracket of the numerator, we can see it will be 3 root 3 into 4, which is 12 root 3, 3 root 3 into 3 root 3, which is negative 27, minus 4 into 4 is minus 16, minus 4 into minus 3 root 3, which is plus 12 root 3. Seeing 12 root 3 and 12 root 3, we can add them and write as 24 root 3. Minus 27 minus 16 can be written as minus 43 by negative 11. To remove the negative sign from the denominator, we can rearrange our answer as 43 minus 24 root 3 by 11. Question number 5. 5 cos square 60 plus 4 sec square 30 minus tan square 45 divided by sine square 30 plus cos square 30. Cos 60 is 1 by 2, therefore cos square 60 is 1 by 2 whole square. Sec 30 is 2 by root 3, therefore sec square 30 is equal to 2 by root 3 whole square. Substituting these values, we can see 5 into 1 by 2 whole square plus 4 into 2 by root 3 whole square minus 1 divided by 1 by 2 whole square plus root 3 by 2 whole square. The numerator will be 5 by 4 plus 16 by 3 minus 1, and the denominator will be 1 by 4 plus 3 by 4, which the denominator automatically becomes 1. Taking the LCM of the numerator, which is 12, we can write the answer as 15 plus 64 minus 12, which is equal to 67 by 12. In question number 2, let us find the correct options for 1, 2, 3 and 4. Question number 1 is 2 tan 30 by 1 plus tan square 30. We know the value of tan 30 is 1 by root 3. Therefore, our numerator is 2 into 1 by root 3, which can be written as 2 by root 3. Our denominator 1 plus tan square 30 is 1 plus 1 by root 3 the whole square, which is equal to 1 plus 1 by 3, and finding the LCM in the denominator, it will be 4 by 3. Seeing a fraction divided by another fraction, we can write it as 2 by root 3 into 3 by 4. We can cancel 2 and 4 and the denominator will become 2. 3 it can also be written as root 3 into root 3. So cancelling root 3, our answer will be root 3 by 2, which is equal to, we know root 3 by 2 is the value for sine 60. Therefore, our correct option is A. In question number 2, 1 minus tan square 45 by 1 plus tan square 45. We know the value of tan 45 is 1. That is 1 minus 1 square divided by 1 plus 1 square. That is 1 minus 1 divided by 1 plus 1, 0 by 2, which is equal to 0. Therefore, our option will be D. In question number 3, we are given sine 2a equal to 2 sine a for a is equal to 0. So let us take our LHS and write down sine 2a, substitute the value for a as 0. Sine 2 into 0, we know 2 into 0 is 0. So sine 0 equal to 0, and in our right hand side 2 sine a, that is 2 into sine 0. Sine 0 is again 0, 2 into 0 is also equal to 0. Therefore, our option is A. In question number 4, 2 tan 30 by 1 minus tan square 30, which is again 2 by root 3 divided by 1 minus 1 by root 3 whole square. Taking LCM in the denominator, it is 1 minus 1 by 3, which is equal to 3 minus 1 by 3 equal to 2 by 3. We can write that answer as 2 by root 3 into 3 by 2. Cancelling 2 from the numerator and denominator, and the numerator 3 can be written as root 3 into root 3, where we can cancel a root 3 and our final answer will be root 3. And we know tan 60 is root 3. Therefore, our correct option is C. Question number 3. If tan of a plus b equal to root 3 and tan of a minus b is equal to 1 by root 3, where 0 is less than or equal to a plus b, less than or equal to 90, find a and b. We know tan of a plus b is given as root 3, but tan 60 is root 3, which shows that a plus b is equal to 60 degree. Mark it as equation number 1. In the same way, we are given tan of a minus b is equal to 1 by root 3. 1 by root 3 is the value for tan 30. So, a minus b is equal to 30 degree. Mark it as equation number 2. Using our elimination method, we can find our answer 2a is equal to 90 degree, and from that a is equal to 45 degree. If a is equal to 45 degree, we can find the value of b is 60 minus 45, which is equal to 15 degree.